Okay, continuing with the substitution method for systems of linear equations. And so let's continue with this method in addition to the addition method. So we have solving the system using the substitution method for this equation, x equals 4y plus 5. And then the second one is negative 2x plus 8y is equal to negative 10. So like the name suggests, we're going to substitute one equation into the other. And you can see here that the variable x is already isolated. So this is easy to substitute the x value or the x variable or the expression 4y plus 5 to x, because that's essentially x. So because we're substituting that 4, 5 into negative 2x plus 8y, we rewrite it as negative 2. And for parentheses, we're substituting 4y plus 5. And then add 8y is equal to negative 10. The reason we do that is it helps us get the second equation all in terms of one variable. You want your equation all in terms of one variable so that you can solve for a variable for that variable. So now we have parentheses and we know to now distribute to negative 2, 4y is negative 8y, negative 2 times 5 is negative 10, plus 8y is equal to negative 10. And we have negative 8y and 8y canceling out, get negative 10 equals negative 10. And this statement is a true statement all the time. It's always true. There's all the variables disappeared. So what this means is these basically are the same two lines. If we were to graph them, right, there would be overlapping lines. So this would be infinitely many solutions for all real numbers. Okay, now we have 5. We're at 5, still using the solving by substitution method. So we have y equals 4 over 7x plus 3 over 7, y equals 2/3 x plus 1. Because it's already isolated, the y's are isolated, we can substitute this expression that's equal to y into the second equation. So we're essentially just setting both equations equal to each other because they're both y's. So we have 4 over 7x plus 3 over 7, and then that's equal to 2/3 x plus 1. Let's try to simplify or get rid of the fractions first. We look at 7, 7, and 3. Let's make this a 1 over 1. We can use a common denominator of 7 times 3, which is 21. And multiply everything by 21. I'm going to do another method that maybe I haven't shown before, which is to multiply everything by 21, which is a common denominator. What that does, if you divide 21 by 7, you get 3. You still have the 4x, so bring that down. You have 21 divided by 7, which is 3 again, and you still have the 3 inside parentheses. 21 divided by 3 is 7, so you have 7 2x. And then you have 21. So now we can simplify further by multiplying everything out. 3 times 4 is 12x, plus 3 times 3 is 9, 7 and 2x is 14x, is equal to 21. Let's gather all the x terms on the left by subtracting 14x. And then we'll get negative 2x. Let's gather all the numbers on the right by subtracting the 9. And that'll give us 21 minus 9, which is 12. And then we can divide both sides by negative 2 to get x by itself and solve for it. So we have x equals negative 6. So now where would we plug in negative 6? Negative 6, where would we plug in negative 6? We would substitute it into the second equation or the first, but I'll just pick the second equation. The equation is y equals 2/3 x plus 1. Plug it in for x. So we have y equals 2 times 3 times negative 6 plus 1. How we multiply 2/3 with negative 6 is make it so that you have negative 6 over 1. Multiply the top, you get negative 12. And then multiply the bottom, we get 3. So it's actually just negative 4. So let's replace this with negative 4. Oops, forgot the negative here. So we have negative 4 plus 1, which is negative 3. So y is equal to negative 3. So you have two values, x and y. So the solution point is negative 6 and negative 3. Okay, let's take a look at number 6, 5x plus 6y equals negative 19. We have, and then 4x minus y equals 8. This one we've actually done as the first problem, right? When we did eliminate y and also eliminate x. And so we could use the substitution method for this as well. So for substitution, you have to isolate or get one variable isolated first. It looks like in this case, none of the variables are isolated. And so I'm looking to see with 5x, 6y, and 4x and negative y, it looks like it's easier to isolate the negative y here. So if we have 4x minus y equals 8, we can add y to both sides and get 4x is equal to 8 plus y, and then subtract the 8 over to isolate the y. We have 4x minus 8 is equal to y. Now we're going to substitute that y into the top y. We have x plus 6 times 4x minus 8 is equal to negative 19. 5x plus, distribute the 6, 24x minus 6 times 8 is 48, negative 19. Add like terms, the x terms, 5x plus 24x is 29x minus 48 equals negative 19. Add 48 to both sides of the equation. And we have 29x is equal to 48 minus 9. It looks like it is 39. Actually, I did my math wrong. That should be negative 19. Okay, take that back. Let's do now 19, negative 19 minus 48. That's negative 29, or positive 29 rather. And then divide both sides by 29, which we would get x is equal to 1. And then you would plug it back. We've done that before in the first for the first problem. But we'll here do the same thing. We'll substitute it back into the bottom equation. 4x minus y equals 8. Let's substitute x into, or 1 into x, with 4 times 1 minus y is equal to 8. 4 times 1 is 4 minus, oops. Be careful here, copying stuff down. Minus y is equal to 8. Subtract 4 on both sides. Get negative y is equal to 4 and divide both sides by negative 1. Y equals negative 4, which is the same thing we got using the addition method, 1, negative 4. Okay, we could also graph this to check the solution. The thing with graphing is that it has to be in y equals x plus b form. So you have to make sure your equation is in y equals mx plus b form. We already got the bottom equation in y equals mx plus b form. It's 4x minus 8. Let's get the top equation into y equals mx plus b form. So 5x plus 6y 19. We'll subtract the 5x over and get 6y is equal to negative 5x minus 19 and divide everything by 6. Now y is equal to negative 5 over 6x. Minus 19 over 6 doesn't simplify nicely, so we got, it's okay, you can still get it into, with fractions, y equals mx plus b form, and here's a second one. So what we need to do is graph both of those and see intersects at 1, negative 4. So let's hop on over to our graphing calculator. Okay, so here we have our graphing calculator, and we're going to go to y equals to graph these two lines. The first one was negative 5 over 6 x minus 19 over 6. And then the second equation is 4y equals 4x minus 8. And we're going to hit graph. Okay, visually, you can see that it does intersect at 1, comma, -4, but let's just make sure. You can go to second calc and go down to number 5 to find the intersection point. It's going to say first curve, which is asking, is this your first line? You say yes by hitting enter. And it's going to ask you, is this your second line? You say yes again. And then it says, can I guess now? And you just hit enter like 3 times, and then it gives you the intersection point automatically, 1, -4. So this is a nice way of visually or graphically checking your intersection point. Okay, so let's go back. The thing with graphing calculators is you have to set it into y equals mx plus b form first. So for this case, you could have also graphed these 2 lines without, right, switching it into y equals mx plus b form because it's already y is also isolated. But for something like number 4, if you wanted to use a graphing method, you would have to isolate the y. And the way it's written out now, you can't just plug it into the graphing calculator. So that's the only thing that you have to watch out for. Okay, let's go to the next one, number 7. It says for a linear function, f of x equals mx plus b, you'll have f of -6 is 25 and f of 9 equals -20. Find m and b. What is this saying? You're given 2 values on the line, essentially 2 points. One is -625. The other one is 9, -20. And we want to find the line where, right, the linear equation that connects those 2 points. So y equals mx plus b, or f of x equals mx plus b. Remember, -6 and 25, these are the x, y values. So this is the x value, that's the y value, same thing for x and y. What we're going to do is write 2 equations using these x, y values, given that we know the slope-intercept form was y equals mx plus b. So the first point, -6 and 25, let's plug in 25 in for y. And we don't know what the variable, that's what we're trying to find, so let's find m and b. And for x, we're going to plug in -6, b we don't know yet. So we use the first point, -6 and 25, to set up this equation. We're going to do the same thing, 9 and -20 to set up the second equation. Y is -20 equals m, x is 9 plus b. Just going to rewrite it into the form we're used to. 25 equals -6m plus b. Keep writing in the negative, watch out for that. -20 equals 9m plus b. At this point, it's really up to you whether you want to use the substitution method or the addition method. It really doesn't matter at this point now that you know how to do both. Now, what's easier for me, I don't have a preference, but it looks like since b is already isolated, we could use the substitution method by solving for b. So if we solve for b, in this case, we have 25 equals -6m plus b. We can solve for b by adding 6m to both sides. And that'll give us 25 plus 6m equals b. Now that b's solved for, we can substitute that into the second b and get -20 equals 9m plus 25 plus 6m. Let's combine like terms. 9m and 6m gives us 15m plus 25. Let's subtract 25 on both sides. Get -45 equals 15m. So now what we have left is divide both by 15. We have m where the slope is equal to -3. We also have to find the y-intercept, and we can find the y-intercept by plugging into the first or the second line. Doesn't matter, but I'll plug it into the second line here. So we have -20 equals 9m plus b. -20 equals 9. Substitute -3 in for m plus b. -20 equals -27 plus b. Add 27 both sides. Get b is equal to 27. the equation that gives us rewriting two equations or finding m and b, we already found m. I don't, so I'll just write it here. Y is equal to the line that goes through those 2 points is negative 3x plus 20. Oop, I made a mistake again. That should be 7 plus 7. And so you can graphically check by putting it into the graphing calculator. Let's graph y equals negative 3x plus 7 to see if it does go through 25 for these two, 6, 25 and 9, negative 20. Okay, so let's go to y equals, clear these two out from the previous problem and put negative 3x plus 7. If we hit graph, what you're looking for is, does it go through negative 6, 25, and 9, negative 20? We can't see it because our window is really tiny. So let's go to second calc and plug in, oops, go to second calc and plug in value. And let's check when x is negative 6, what's its y value? It says 25, so it's really up here, but I can't see. So we've checked that it does go through negative 6, 25, and check for the other value as well. Hit value, and then x, when x equals 9, let's figure out what y value is. So it is negative 20, so it does intersect at 9, negative 20 as well. You can always change your view if you want by going to zoom and zooming out. And then checking that way as well. And if you want to go back to your normal view, you can change it back to standard, going to number 6. Okay, this is the last question I had for you. Please let me know if you have any questions on what we just discussed today. And I hope you have a great rest of your day.